Hello everyone, today I'm going to be talking about the bucket sorting algorithm for Cisc 220. So what exactly is bucket sorting? Well, it's exactly what it sounds like. You sort the data by buckets. Got some data? Throw it in a bucket. I'm going to be using integers as an example, but you can use this with floats or the ASCII values of characters and strings as well. So when we're using integers, you want 10 buckets total, going from 0 to 9. That corresponds to all the integers. And here's a randomly generated list of numbers between 0 and 1,000. So the way we decide which buckets to put this data in is by using the least significant digit, or the digit that's the farthest to the right. And we'll place that data into the corresponding bucket. So 82 would go in the 2 bucket, 149 would go in the 9 bucket, 39 would go in the 9 bucket, 320 would go in the 0 bucket, and 685 would go inside of the 5 bucket. A note when implementing this practically, you want your array to either be an array of linked lists or a two-dimensional array, because you can have multiple entries with the same least significant digit. And remember, we want to keep all of our data. Now, the beautiful thing about the bucket sorting algorithm is that you can use other sorting algorithms within it. Once your data is in the buckets, you can apply the individual sorting algorithms based on which kind of data is in those buckets. And then you simply remerge the list at the end and boom, you get a sorted list. This will vary the efficiency depending on the sorting algorithm used, but since you're able to tailor the bucket sorting in so many ways, it's pretty nice. Now, if you don't want to do all that and you just want to brute force run through this list, you can use what's called the radix algorithm. Now, the radix algorithm is simply doing the same thing we did in the first step over and over and over again until you run out of significant digits. So we're going to remerge the list. As you can see, it's still not ordered. 320 is at the front. We're going to put them into even more buckets using the next least significant digit, aka the one to its left. So looking at this list, we're looking at the second least significant digit. 320 would go into the 2's bucket, 82 would go into the 8 bucket, 685 would also go into the 8 bucket, 149 would go into the 4 bucket, and 39 would go into the 3 bucket. Remerge the list to see if it's all sorted. It's still not. So we do that step one more time. 320 goes into the 3 bucket. 39 goes into the 0's bucket because if we look at the number 39, it has a 0 in the 100th place, so it counts as 0. 149 goes into the 1's place, 82 also goes into the 0's place, and 685 goes into the 6 bucket. Remerge this list one more time, and boom! Mathematically, it's all sorted without having to do any actual comparison tests. Great! We've got this really awesome algorithm that can sort things without actually doing comparison tests. Let's try it with some even more numbers. 56, 900, and then this long thing. Oh no. This is where some problems start to come in. If you're not using the radix algorithm, the efficiency of the bucket algorithm is directly correlated to the efficiency of the sorting algorithms you use within the buckets. So its efficiency and its stability will be determined by that sorting algorithm. Some sorting algorithms are better at storing different types of data, so you want to choose wisely when you're looking at the sorting algorithm for each bucket. If you're just using the radix algorithm, the runtime is a little bit more simple. Since we go through the list n times for each piece of data, and k times, where k is the largest number of digits within the largest number, it's O of n times k, which is great for if you have smaller lists of numbers that aren't really large, but can get pretty cumbersome if you have really large numbers like credit cards, social security, and other pieces of large data. Other issues can come with the actual implementation. If you're using linked list, it can be a little bit complicated to rearrange the list every single time you want to reorder it, or you can run into duplicates. If you're using a 2D array, this isn't as confusing or annoying as the linked lists, but it is a lot more memory intensive, especially if you're using longer numbers. This algorithm is also not stable. If you put in 87, 87, 87, 87, it's not going to be able to tell you which of those 87s is the first, the second, the third, and the fourth. So you lose all distinguishability between the pieces of data. And it is also not in place because you need to make new arrays every time you go through the radix algorithm. So ultimately, the bucket algorithm offers you a great amount of freedom in choosing how to sort your data. But as Uncle Ben said, with great power comes great responsibility. You have to choose sorting algorithms that will best fit your data within the bucket, or knowing if the radix algorithm is right for you. That's all. Thank you.